You know, for the last, 30 years or so, almost every single piece of tech you own, your phone, your laptop, even your car, it's all been powered by the same thing. But that's all about to change. And the key? It might just be something you've got in your kitchen. Yeah, really. Let's dive in.
So think about this for a second. What if the future of batteries, the key to making them cheaper, safer, and way longer lasting, what if it wasn't some super rare metal from halfway across the world? What if it was, I don't know, sitting right there in your salt shaker, or just floating around in the ocean? I mean, for decades now, there's been one battery to rule them all, right? Lithium-ion. It's in everything. Our phones, our laptops, the EVs that are completely changing how we get around. It's been the undisputed king, no question about it.
But the thing about kings is their reigns don't last forever. And this king's throne is starting to look a little shaky. The crown is heavy, and you can definitely start to see some cracks forming.
Okay, so here's the deal. The big problem is that lithium and other stuff you need for these batteries, like cobalt and nickel, is what they call a critical mineral. And that's a fancy way of saying we need it, but we can't always get it reliably. The supply is concentrated in just a handful of countries, and that leads to all sorts of headaches. Crazy price swings, geopolitical drama, and even real safety concerns just getting it from point A to point B.
And this is where our challenger steps into the ring. Enter sodium-ion. Now, mechanically, it works a lot like a lithium battery, but it has this one huge fundamental advantage, something that lithium just can't compete with, ever.
It really all boils down to this one incredible fact. Take a look. Sodium makes up 2.6% of the Earth's crust. Lithium? A measly 0.005%. That makes sodium more than 500 times more abundant. It's literally everywhere.
And that abundance? It changes everything. You can get sodium from seawater, from salt flats, using methods we've known how to do for ages. And crucially, it's not a strategic mineral. So all that drama with trade disputes and export bans that plague the lithium world, yeah, sodium just sidesteps all of it.
Okay, so you're probably thinking, if it's so common and great, why aren't all our batteries made of salt? And that's a great question. For a long time, there were these myths about its performance. But as you're about to see, reality has not only caught up, it's completely rewriting the rulebook. Right, so the old story went something like this. Sodium batteries are just too clunky, too heavy, not enough punch for their size. Their energy density was just too low. Sure, maybe they were okay for, a giant battery sitting in a field, but for something that actually has to move, like an electric car, forget it, a total non-starter. Well, that myth is officially dead. Take a look at this. CATL's new generation of sodium-ion cells. They're hitting 175 watt-hours per kilogram. Now, to put that into perspective, that's actually more than the common LFP lithium batteries you find in a ton of EVs on the road today. Now, okay, it's not quite at the level of the super high-end NMC lithium batteries yet, but this proves it. Sodium-ion is no longer on the sidelines. It's a real player in the EV game.
But hold on, energy density is just one part of the equation. Let's talk about longevity. How long do these things last? Well, CATL is claiming its new sodium-ion battery can last for, get this, 3.6 million miles. I mean, just let that number sink in.
So what does that even mean? It means it lasts 3 to 6 times longer than the absolute best lithium batteries you can buy today. Your car would literally rust and fall to pieces around this battery before the battery itself started to seriously degrade. This isn't just an improvement, it completely redefines what the lifespan of a battery even is. And then you get to the price tag. CATL has gone on record saying they're making these cells for just $19 per kilowatt hour. 19! For comparison, the standard LFP cells cost somewhere around $55 to $60. This isn't just cheaper, it's a completely different economic reality. It's a massive disruption. And the hits just keep on coming. It's not just about cost and how long they last. You know how lithium batteries hate the cold? Sodium-ion batteries are champs in extreme weather, keeping over 90% of their juice even in a freezing -20°C. Plus, and this is a big one for safety, you can drain them completely to 0 volts. That makes them way, way safer to ship and store. Okay, so the tech specs are obviously super impressive, but the real revolution here, the thing that could change everything, isn't just about better cars. It's much bigger than that. It's about
who controls the power? So here's the secret weapon that could make this happen fast. You don't have to build brand new, crazy expensive gigafactories from scratch. You can make sodium-ion batteries on the exact same assembly lines that are already making LFP lithium batteries. It's what they call a drop-in technology, and that is a huge deal.
And that's why this matters so much. When the materials are everywhere and you can use existing factories, suddenly countries don't have to rely on complex global supply chains. They can start building out their own energy storage with what they have right at home. We're talking about a path to real energy independence.
So is this the end for lithium? Is it game over? Well, not so fast. The future probably isn't sodium or lithium. It's something way smarter. It's sodium and lithium. The big players are already working on what they're calling a hybrid AB battery system. The idea is simple. You put both sodium-ion cells, that's the A, and lithium-ion cells, that's the B, into the same battery pack. Then you let some clever software manage them to give you the best of both. It works like this. For your everyday stuff, your commute to work, driving around town, the super cheap, super durable sodium-ion cells are doing all the heavy lifting. But let's say you're heading out on a long road trip and need that extra range, or you want to floor it for maximum acceleration. The software just seamlessly brings the high-powered lithium cells online to give you that boost. And this hybrid approach is a great way to make EVs cheaper. As we saw, the cost of the sodium-ion cell itself is already crazy low. But if you really want to see where the big savings are, you have to look inside the battery pack itself. It's all about the materials.
Okay, look here. There are two huge game changers. First, the cathode. That's usually the most expensive part of a lithium battery because it's full of lithium and cobalt. With sodium, it's way, way cheaper. Second, see the current collectors? In a lithium battery, the anode side needs expensive copper. In a sodium battery, you can just use cheap, ordinary aluminum foil on both sides. That one change alone saves a ton of money.
You know, when you step back, this is a really fundamental shift. Lithium-ion was the age of progress, for sure. It got us here. But it was always built on something scarce and expensive. Sodium feels different. It feels like the age of permanence. It's built on something that's everywhere, something sustainable that we can rely on for generations to come. And that leaves us with one last big question. What happens when the ability to store energy is no longer tied to rare metals controlled by just a few powerful players? What happens when it's available to everyone, everywhere, using common salt? What does that world look like? Maybe, just maybe, this is what the beginning of real energy equality looks like.